So now let's talk about acid-base properties of salts. When we talk about strong acids and strong bases, okay, like HCl or HNO3 or NaOH, our conjugate, in other words, the Cl minus, the Na plus, the NO3 minus, none of those conjugates are acidic or basic. They are neutral, okay? So for example, if we talk about HCl, its conjugate base is Cl minus, but it is the conjugate base of a strong acid. Therefore, it is neutral, because in order for this conjugate base to be basic, it has to be able to pull protons off of water. Because Cl minus is so weak that it doesn't hold on to protons well at all, why HCl completely dissociates. Therefore, it is neutral because it can't dissociate any of the water molecules to make OH minus. Conversely, or another example of a strong base is NaOH. Na plus is the conjugate acid, quote unquote, of NaOH. Because it is the conjugate acid of a strong base, it is also neutral. Therefore, a solution of sodium chloride, which are two counterions or conjugates of a strong acid and a strong base, those conjugates are neutral, and so a salt solution is a neutral solution, at least when we're talking about sodium chloride. When we talk about weak acids and weak bases, the conjugate is acidic or basic. So for example, we've been talking about hydrofluoric acid quite a bit. And as we have found out, F- is a conjugate base of this weak acid. Therefore, if I make an F- solution, it will be a basic solution. Also, because F- has a conjugate acid, is a weak base, its conjugate acid will be acidic, okay? In our case, we have found out that HF is much more acidic than F- is basic, but nevertheless, if you dissolve F- in solution, you get a basic solution. If you dissolve HF in solution, you get an acidic solution. So those weak acid, weak base conjugates are basic or acidic no matter what the situation is. So if we talk about a solution of sodium fluoride, we can say, okay, let's look at the positive and negative ion. Sodium is a positive ion. It is the conjugate acid of a strong base. Therefore, it is neutral. Fluoride is the conjugate base of a weak acid. Because it is the conjugate of a weak acid, it is a basic conjugate. Therefore, overall, when we dissolve sodium and fluoride in water, we get a basic solution. Metal cations as weak acids. Now, cations of small, highly charged metals are weakly acidic. For instance, alkali metal cations and alkali earth metal cations are pH neutral. Why? Because they are conjugate acids of strong bases. But transition metal cations, as well as aluminum, or things like iron, cobalt, lead, I believe, might also be in this category. All of these metallic ions are weakly acidic because they interact with H2O, okay, and as we're going to find out later, this is actually a Lewis acid-base interaction that produces a complex ion. And what can happen is the H2Os bound to this hold on to their hydrogens a little less tightly, so one of the H2Os can lose one of those hydrogens to form acid. And this is the reason that mine tailings are often very acidic and are of considerable concern to the environment. Places where there's a lot of heavy metals around create pH unbalanced water. In other words, acidic water that can pollute streams and fields and various things and lead to fish deaths and things like that. So metallic contamination is a big deal. So to summarize, if here we have a table and we kind of do a little comparison, okay? So we have cations over here and anions over here, okay? And we just go down the list. So for instance, if we have the conjugate acid of a weak base, it's going to be acidic. If we have the conjugate base of a strong acid, it's not going to be basic. So if we have a salt made of these two things, we get an acidic solution. If you have the conjugate base of a weak acid, now we have a basic species with an acidic species, and so now we have to think about the relative strengths of things, okay? If we have a small, highly charged metal ion, we have just learned that those tend to be acidic. So if we couple that with the conjugate base of a strong acid, which is neutral, we have neutral plus acidic is acidic. If we have the conjugate base of a weak acid, we have acidic plus basic, and we've got to think about the relative strengths of each thing. And I could, if I ever wanted you to think about the relative strengths of things, I would give you the Ka and Kb that you can compare, okay? Stronger bases, stronger acids have larger values of Ka or Kb, okay? Now, let's say we have the counter ion of a strong base, like sodium plus, okay? That is neutral. So if we combine it with the conjugate base of a strong acid, we have a neutral solution, like NaOH and HCl. Na plus Cl minus is neutral, okay? Its salt solution is neutral. If, on the other hand, we combine that strong base, like Na plus, with the conjugate base of a weak acid, like our fluoride ion, that solution will be basic because we have neutral plus basic yields basic, okay?